Good day, Algebra 2. This is the final review day video for 2019-2020 first semester. So yay, so I guess it's 2019, right? Because I still got videos for next semester. Anyways, so today we're going to be going over solving quadratics through the various methods. Now I did say on the test you can use whatever method you want preferred. I think most people were going to be using quadratic, and that's fine. A lot of steps in there. But you're going to see that depending on the type of equation, some other methods are a lot faster and require so many steps. So this review today is intending to help you see those methods and refresh your memory. So without any further ado, let's go ahead and start. We have solve by factoring. So factoring was the first method we learned. And what we're going to do is just ask ourselves, okay, so first of all, can I simplify this equation if possible? And notice that all my coefficients are divisible by 3. So I'll divide them all by 3, and I get the resulting equation of x squared minus x minus 20 equals 0. This is easily factorable. Now all I need are two factors that multiply to give me negative 20 and add up to give me a negative 1 for the negative 1x. And those factors would be negative 5 and positive 4. Remember, these are just the factors. These aren't the solutions. The solutions are arrived at when I solve each equation after making it equal to 0. So I took both my factors, make them into equations equal to 0, and then I solve for both of them. I get x equals positive 5, and then when I subtract 4 over here on the left and right, I get x equals negative 4. So my solutions for x are at negative 4 and at positive 5. For number 2, this one I cannot reduce, but I do need to make it into standard form, and I'll do that by subtracting the 3x from the right and bringing it over to the left side. When I do that, I get 4x squared plus 28x equals 0 because there is no constant. So 31x minus 3x gives me the 28x. Now this is actually very easily factorable. 4 and 28 can both be divided by a great common factor of 4. And then I have two x's in the x squared and one x there, so I can take out an x. So if I divide everything by 4x, I get 4x on one side. When I take out the 4x, I have just a single x left over because I took out the 4 and one of these x's. 28 divided by 4 is a positive 7. And then that one x went away when I divided it out. So here's my second factor. I make each of these equal to 0. And when I solve them, 4x equal to 0, when I divide by 4, 0 divided by 4 is still 0. So there's my first factor. I subtract 7 from both sides. I get x equals negative 7. So there's my solutions. My solutions for x are at negative 7 and 0. All right, so those are the first two for factoring. Now we're going to solve by square roots. Solving by square roots basically means getting x by itself and solving it like a one or two-step equation. So what I'm going to do first for this first equation is I'm going to go ahead and divide everything. Let me combine my like terms and get x by itself. I'm going to add 8 to bring it over to the other side to get the x all by itself. So now I have 9x squared equals 7 plus 18, which is 25. To get the x squared by itself, I need to divide everything by 9. And then now I get x squared equals 25 ninths. To get x by itself, I square root the left side and the right side. Properties of exponents tell me that when I'm square rooting a fraction, I square root the top number, which is 25, and I square root the bottom number, which is 9. In this case, I'm going to get, don't forget, you get a positive and negative version of 5/3 in this case. All right, so don't forget that, and let's go ahead and do the next one. For number 4, we have 1/3 x squared minus 7 equals 43. What we're going to do is go ahead and add 7 to both sides. 1/3 x squared equals 43 plus 7, which is 50. To clear up that fraction, I multiply times the reciprocal, 3 over 1, on the left and on the right. Basically, 3 over 1 means multiplying times 3. So I get x squared on the left remaining. 50 times 3 is 150. Now I find the square root, of both sides. get x equals the square root of 150. When I do that, I go ahead and have to break down 150 because 150 is not a perfect square. But I can break it down to 25 and 6. 25 gives me plus or minus 5 for an answer, and the square root of 6 is just square root of 6. So x will equal plus or minus 5 square roots of 6. So if I go back to my answer key for number 3 and 4, for number 3, it was plus or minus 5/3. And then for number 4, x equals plus or minus 5 square roots of 6. Going on. Numbers 5 and 6. Solve by completing the square. This one was probably the least popular method, but kudos to those of you who like to use it. First of all, I am going to go ahead and going to bring the 134 to the other side. So I'm going to subtract 134 to both sides, and I get 2x squared plus 8x on the left, excuse me while I try not to burp loudly into the microphone, equals negative 134. Now what I'm going to do is I'm going to go ahead and simplify everything. Everything's an even number, so I can divide it all by 2. Now I get x squared plus 4x equals negative 67. I can take this b value, the 4, cut it in half, which is 2, and then I gotta square it, which goes back to 4. So that seems kind of pointless, but that is the method you use. And you add that both to the left side and to the right side of your equation to make it a perfect square. So I have x squared plus 4x plus 4 equals negative 67 plus 4, which is negative 63. Now I go ahead and I'm going to factor this, because I should have a perfect square factor. Two numbers that multiply to positive 4 and add up to positive 4, that would be plus 2. So what I have then is the factor x plus 2 times itself, or squared, equaling negative 63. And then I'll just do what I did in the very beginning of my first examples. I have x plus 2 squared equals negative 63. I square root the left and the right side, and I get x plus 2 equals the square root of negative 63. We can't do negative 63 because it's a negative, so we break it down to negative 1 times square root of 63. And 63 is not a perfect square, is what I meant to say. And to break it down even further, to get a 63, I would have a 9 and a 7. So I have the square root of negative 1, which is I, that's part of my answer. Square root of 9, which is plus and minus 3. That's an ugly sign, plus and minus. There we go. You know what, let me just erase that. It's going to bug me saying that nonsense. Alright, so I have plus or minus 3 right there. That's a lot better. And square root of 7 cannot come any further. But I still have this plus 2. So I have to subtract 2 to get the x by itself. So here's how my final answer is going to look. I have plus 2. I need to get rid of that. So I will have a negative 2 to start off my equation. Now I have the plus or minus 3i with the square root of 7 attached at the end. Yikes. So that one was kind of messy, but that is legit how it works. And number 6 has the same kind of process. Let me change color because I'm getting a little annoyed with that. All right, so the first thing I'm going to want to do is I'm going to want to bring the minus 7x on the left and on the right to combine those like terms. And when I do that, I get x squared plus 5x. And then I have the 1 on the other side. Oh, I just realized, but it says it wants a quadratic formula. So I need to bring the 1 that was over here on the right to the left, so I'll subtract 1. So now my equation is standard form, x squared plus 5x minus 1 equals 0. All right, so I get my a, my b, and my c. My a is the 1x squared, my b is the 5x, and my c is the negative 1 at the very end. Using all those, I'll start substituting x equals plus or minus, negative b, let me erase that, not be sloppy or lazy. It's going to be negative b, which is negative 5, plus or minus the square root of b squared minus 4 times a times c over 2a. When I work that out, I get x equals negative 5 plus or minus, and in the house, I get 29 all over 2. And 29 can't be broken down at all. It's a prime number in and of itself. And negative 5 and 2 cannot be simplified any further, so that answer I can leave in that form. So to continue my answer key over here on the upper right-hand side, I now have for number 5, x equals negative 2 plus or minus 3i times the square root of 7 for your solutions. And then for the next one, I have x equals, in fraction form, negative 5 plus or minus the square root of 29 divided by positive 2. Those are nice, complex answers, for sure. And now on the back side, they give us 4 equations. We were asked to find the discriminant in each box, A, B, C, D. I'm ignoring all that for this quiz. We have 4 equations to choose from, and I'm allotted in each box. I'm allowed to pick any equation and use the method in the box. So I'm going to go ahead and adhere to the instructions. If you want to use one method over and over and over again, be my guest. But I'm going to go ahead and show you how easy it is to use different methods for different types of equations. So for the factoring method, I'm going to go ahead and use equation C from above. Equation C from above says 4x squared minus 21x minus 18 equals 0. So what I'm going to go ahead and do for this, I'm going to divide everything by 4, because everything is divisible by 4 in this case, to make it simplify it. So I get x squared minus 7x. Let me keep going. My bad. I forgot what I was going to do here, and I'm not sure why I made this mistake. Oh, that's what I did. I'm doing factoring. Hold on. And that's why my answer didn't make sense. I knew I had the 4. Let me erase this. Why is my eraser not working? Let's see. Okay, there we go. So let me start all over again with my equation C. I got my methods confused there, pardon me. So here I go again. The original equation is 4x squared minus 21x minus 18 equals 0. I have to get rid of that 4 in order to factor. I can't have this 4 in the front. So this one I multiply it times the last constant at the end. So I get x squared minus 21x minus 72 equals 0. That was the first step. Okay, so I know it's been a while since we've done it, so forgive me. Now I'll go ahead and factor this equation. I get x and x. Two numbers that give me a negative 72 when I multiply them, but add up to a negative 21 when I combine them, and I get x minus 24, and then I get x plus 3. However, the 4 that I multiplied by doesn't go away. Because I multiplied my answer in the beginning by 4, I now have to divide these second answers, the numeric parts, also by 4. And when I do that, I get the resultant factors of x minus 24 divided by 4 is 6. And then I get x plus, I'll just leave, to solve this, oh, here's the little trick. When you have 3/4, that can't be simplified any further. What I'm going to do is take this 4 and put it in front of the x. So I get 4x plus 3. That's how you handle the fractions that don't simplify. Now, just like I did in the previous examples in the beginning, let me get rid of that parentheses actually. I set each factor equal to 0, and I solve for it. I get x equals positive 6. I get 4x plus 3, set that equal to 0. When I solve for x on both sides, 4x equals negative 3. Divide both sides by 4, and you get x equals negative 3/4. That's a negative sign right here. There we go. So basically, you could have still gotten that just from reading this equation and doing the opposite. No joke. A lot of people saw that when they did factoring originally. For square roots, moving on, I'm going to do the A equation, which is negative 2x squared minus 196 equals 0. This one has the fewest parts, so it's easier to solve like just a regular 2-step or 3-step equation in this case. I'm going to add 196 to both sides. When I do that, I get negative 2x squared equals 196. Divide both sides by negative 2 to get the x squared by itself. When I do that, I get, negative 98. Square root that, I get x equals, now negative square root, or the square root, negative, let me rephrase that, square root of negative 98. I have to use the negative 1 and the positive 98. 98 can be broken down to 49, which is a perfect square, times 2. So the square root of negative 1 is always going to be I. Square root of 49 is plus or minus 7. And the square root of 2 is just the square root of 2. So my answer is x equals plus or minus 7i square roots of 2. So go ahead and box that in. Now let's go on to the bottom two. I'm left with completing the square and the quadratic formula. And I have two equations left above that I haven't used. I'll use choice D for completing the square. The equation for choice D is x squared plus 18x plus 97. The first thing I'm going to do is, equals 0, excuse me, is move the 97 to the other side of the equal sign to get the x's by themselves. So then I get x squared plus 18x equals negative 97. Now I have to take that b value, cut it in half. So 18 divided by 2 gives me a 9. I square it. So I'll draw little arrows of progression here. I get 81. That is what I have to add back to my equation on both the left side right here, oops, 81, and on the right side over here. When I do that, I need to now factor the left side. I need two factors that multiply to 81, add up to 18, positive on both ends, so it's x plus 9. Negative 97 plus 81 is negative 16. So on the left, I have the factor of x plus 9 times itself equaling negative 16. I'll go ahead and just solve this. I'm going to go ahead and square root, let me rewrite it over here to make some space. So I have x plus 9 in parentheses squared equaling negative 16. Square root the left, square root the right. I get x plus 9 equals the square root of negative 16. Negative 16 has to be broken up into negative 1 and positive 16. Negative 1 turns into I. There we go. And then the square root of 16 is plus or minus 4. So I have x plus 9 equals plus or minus 4i. But I need to get x by itself. So to get x by itself, I'll subtract 9 from both sides. So the way I write my final answer is x equals, I had that negative 9 that I brought to the right side, plus or minus 4i attached at the end. And that is that solution. And my final equation left is going to be equation B, and I will apply the quadratic formula. The equation is 2x squared minus 9x plus 8 equals 0. My A value is 2, my B value is negative 9, my C value is 8. Begin my substitution. X equals negative B, which turns this to a positive 9, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. Simplification. I'll go ahead and do the radical part first. When I simplify everything in the radical, I get 17 over 4. And 9 cannot be divided by 4. 17 is prime. We don't even care about the radical number there. 9 and 4 cannot be simplified any further. So your answer is just officially x equals 9 plus or minus the square root of 17. Oops. 17, 1, 7 positive, divided by 4. All right, so there's an example of all 4 methods used and the review for your final review for the second 9 weeks exam. Hope this helps you guys, and add whatever examples you might need to, or make any notes to yourself for your exam on your note card. Best of luck.